the background again you've got the radio going, so you know what day it is. There's gales in Scotland, okay? So a few days later I've got this resistor, homemade resistor. As you can see, it's just a piece of aluminium which is coated with plastic. In fact, I'll show you what it is. It's a soup packet, right, with the paper stripped off of it, and then I've got it soldered. See the solder? I've soldered contacts to it to get through the insulating plastic, and it's acting as a resistor on the battery. Now this has been on for quite a fair old few hours now. What I'm going to do, I'm going to turn the camera off for a second. I'm going to set up all the meters on it and show you what's happening. I've just left it like this for days and days and days, like it basically, and it's just sitting there draining. Or is it draining the battery? Is it still working? Oh, I know what's happening. It's still working, I'm telling you. Right, I'm going to put all the meters on it now and show you what's happening. And I've got the voltmeter set up into 2000 millivolts, and there's the earth terminal. The positive's in the positive. I'm just going to stick the earth into the earth, into earth, and I've got 8 millivolts still. This is after days and days and days and days and days. It's still producing 8 millivolts. Right, so I've took the thing out now. Yeah, if I touch my finger onto it, look how many millivolts I'm discharging. That's with me touching the earth. Well, no, I need to make the circuit through that. So if I put myself through it, you know, I'm producing 26 millivolts, you know, like I should do, and it'll go up to a lot of millivolts. So that's volts. Now I'm going to show you amps. So I'll just get it set up. So I'll turn the camera off. Right, so I'm drawing 2 milliamps still. Hang on, I'll get the volts going as well. And I've got, so let me just get the volts going as well. I've got 0.9, 0.9. So I've gone up with volts now because I'll put the amp meter in now. For some stupid reason, I've actually gone up in amps. So there we go. Let's take it out. Let's zoom out, and we can go across. We can see the 2 meters, and I'm holding one in there. Like, yeah, we've got the amp meter in it. It says -2 because I've got the leads the wrong way around. Because I love putting the leads in the wrong way around. So I've got 2 amps. Sorry, 2 milliamps and 9 millivolts out of 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30 square centimetres, not cube centimetres, of aluminium. Right, and as you can see, if I zoom in closely, not all of the aluminium's actually touching the soil or touching the tea leaves, because it's tea leaves. Right, so this is a really badly constructed earth battery, but after days and days and days of being on a resistor, permanently on that resistor, just constantly contacting, it's not going to heat it up too much because it's only a couple of milliamps and a couple of millivolts, but it gives your tongue a good buzz when you put your tongue on it. You know what I mean? You know when you put your tongue on a battery, on a 9-volt battery, and it gives you a good buzz. Well, this is an 8-volt battery. This is 8 volts, so it gives you a good buzz. It's actually we've actually got a rising voltage. That's probably because I'm moving my finger on the conductor, but I'm actually getting a rising voltage. I've actually got 10 millivolts now coming out of it, and I've still got 2 milliamps. And then, like I say, that's been linked up for days and days and days and days and days and days. So you work out how many. Let's say that was 8. How many 8 milliamps and how many 8 millivolts and how many 2 milliamps is going to be enough to make that run. You know, you want to fill your attic up or fill your cellar up with those, get completely free electricity forever and ever and ever. All you've got to do is top up the electrolyte with a little drip system. But unfortunately for that, I mean this has been for days in a heated house. Yeah, it's heated. It's a little bit dry. Is there any left? No, it could do with topping up. It could definitely do with topping up, like, yeah. So I just need to drip a little. I just need to eat some more. I just need to eat some more pickles, and I'll get some more vinegar. Or I could wee in it. Obviously, you don't want to wee in it because it smells a little bit. The pickle smells quite nice, but the wee would smell horrible. But you could just wee in it, and then produce electricity from wee. And of course, the more cells you make, the more ampage, and the more voltage you make, and then the more power you get for doing stuff with. Now, Tesla tried to make Tesla coils. Shall I make a Tesla coil and show you how a Tesla coil works? I think I'll make a Tesla coil next and show you how I can transmit electricity from an earth battery into a Tesla coil and make a radio-controlled car work.
Now, what you're actually seeing in that video is the battery is under load. Okay. Now, when the battery's when the battery's off load, its free voltage is around about 7.5 to 8 volts, depending on when you get there. It fluctuates quite a lot in between, around about 7.3 to be honest with you, about 7.3 volts and up to close to 8 volts. But it's just over 8 volts I've measured it at as well. So like when I was saying in that video there that it's like having a 9-volt battery on your tongue, it is. I'm not joking. You know, when you put them on a 9-volt battery, you go, well, I've just got a 9-volt battery anyway, just to demonstrate a 9-volt battery. We got one? We got. So when you get a PP3 battery and do this, you know, you get that little off your back, and this one's at 9 volts. But that earth battery is at 8 volts instantly. Obviously it drops a lot quicker than the well constructed battery. Like here I've got a 2000 milliamp hour battery. Okay, now that gives you a big wallop because it's 2 amps and it's very, very small. It's well constructed. This earth battery that you're looking at is 2 milliamps, not 2000 milliamps, it's 2 milliamps, and that battery you just looked at is 1.2 volts. This thing you're looking at is 8 millivolts when it's under load, but when it's off load, when it's just sitting there, it quickly raises itself right the way back up again to 8 volts. So if you've got a frequency going, like a duty cycle, you can duty cycle to a certain voltage and a certain ampage, because it does give you a whack of an amp. It'll whack something straight out at you like that. And like I'm saying as well, there's only, what did I come out with? Is it 30 square centimetres of aluminium in that as the anode, as the cathode. And as for the anodes, it's just stripped wire. You can see the wires bending over inside, the batteries looping over. All I've done is just stripped off the end of the wire and dipped that inside the tea leaves with the electrolyte, and I'm getting that amount of milliamps and that amount of voltage out of it. This is a really poorly constructed battery, just to demonstrate that earth batteries, they don't run out. They fluctuate up and down with the earth's magnetic field and what have you. And by the way, that earth battery is situated just off the north-south, and it's actually back to front. If I turned it round the opposite way, it would increase its voltage and its amperage a little bit. It's actually orientated just off the north-south line and back to front, to show you that you can even make them back to front as well. And these things, they will just produce on and on and on. And when it rains, if you make an earth battery, every time it rains they get more powerful. If you have a drought and there's no water, then they stop working. Oh, they stop working if there's no water. But if you wee on them, they produce more ampage and more voltage, because, well, water's a pretty good electrolyte, but urine's a miles better electrolyte, and vinegar is as well. It's absolutely amazing, isn't it, what we could actually do if we actually tried. I mean, you could have it like in a field with cows on it. You have the cows walking around and eat the grass, have these buried in the ground with insulators to make them work properly, yeah, so it would be some kind of construction beneath the ground, and have the cow wee going down on them, or have a section of, there's countless possibilities of how to make these things to produce electricity on a constant basis. Like a solar panel produces electricity constantly during the day, and a wind turbine produces electricity constantly when it's windy, and an underwater turbine produces electricity when the tides are going in or out constantly, but obviously on the changeover point they don't do nothing. Obviously when it's dark, a solar panel doesn't do a lot, although they do produce electricity at night, because mine produces 4 volts, because I live in a city and I've got street lights everywhere. It produces nearly 20 volts during the day, on a nice hot sunny day. On an average kind of day it produces 15 volts, and on a overcast rainy night but with the street lamps it produces 4 volts. It's miraculous, isn't it? And then the wind turbine, well, the wind turbine produces so many amps when it's windy and so many volts when it's windy. But if there's no wind at all and you just go up there and just start winding it around with your finger, it produces electricity then. But these earth batteries, you don't have to do nothing, you just have to keep it wet and moist, and the earth does the rest of it. And that's a tea leaf battery, made out of tea leaves and beetroot vinegar. There you go. Buzz your tongue, it buzzes your tongue.